So continuing with the unit of thermodynamics, students of 11th class, today's topic for you is thermodynamic properties and thermodynamic processes. First, let me come to thermodynamic properties. There are two thermodynamic properties. One, thermodynamic properties. One, intensive thermodynamic properties, and second, extensive thermodynamic properties. Now, first, let us come to intensive these thermodynamic properties. Which properties of a system are known as intensive thermodynamic properties? The properties of a system, which do not depend on the size or quantity of the system are known as intensive properties of system. So, intensive properties of a system means, suppose if we have a system and let me take an example of a system. Suppose this is a container . Now I have this is suppose its capacity is 1 liter and I have kept 1 liter of kerosene in it, K oil, and suppose its temperature is 30 degrees centigrade. Now I have a container of 1 liter capacity and there is a system in it. This system is in contact with the surrounding and its temperature is 30 degrees centigrade. Its temperature is 30 degrees Celsius. Now, what I do, I take half of this. That is, I am decreasing its quantity. I am decreasing its size. Suppose I take another container now of lesser capacity and I put half liter in it, 1/2 liter. That is 1/2 of this. Now, what will happen to its temperature? Will temperature become 1/2? No, the temperature will still remain 30 degrees C. So what has happened to the temperature when I decrease the size, decrease the quantity of this system? No change in temperature. So temperature is an intensive property of a system. So such properties of a system which do not depend upon the size, which do not depend upon the quantity of the system are known as intensive properties. For example, temperature is an intensive property. Similarly, pressure is an intensive property. Pressure. Then density of a system is intensive. Why? Because density of a piece of iron, whether it is 1 kilogram or 1 quintal, is same. If it is made up of similar material, then its density is same, so it is an intensive property. Similarly, viscosity is an intensive property. Surface tension is also an intensive property. So these are some refractive index I can name, which is also an intensive property. So these all properties, whether surface tension, the refractive index, the viscosity, the density, the pressure, the temperature, these are such properties of a system which do not depend on the size of the system, the quantity of the system. Irrespective of system, they remain as they are. So such properties are known as intensive properties. Now coming to extensive properties. Extensive is quite reverse of the intensive. That is, these are those properties of the system which depend on the size or the quantity of the system. Size or quantity of the system. They change with the size of the system. They change with the quantity of the system. Such properties are known as extensive properties. For example, I take this example again. Suppose I had taken 1 liter of kerosene. So what was the volume in this case? The volume was 1 liter. Now what I do, I take 1/2 of this, as in this case, 1/2, that is half a liter. So what will be its volume? Its volume will get 1/2. So it has changed. It has not remained same. It has changed when I decrease the quantity. It has changed when I change the size. So those properties which change with the size, which change with the quantity, are known as extensive properties. For example, volume. Volume is purely an extensive property. Similarly, heat capacity is also an extensive property of a system. Then we have mass. Mass also is an extensive property of a system. So these are some examples of extensive properties of system. Now coming to suppose a system, this is a system, suppose it changes to another system. This is system A, it is getting changed to system B. Now what happens? During this process, that is during the process when a system changes from one form to another, one state to another, during that there are certain changes are observed. Certain changes take place during the process. For example, there can be change in pressure. There can be change in temperature. Pressure change when a system changes. There can be temperature change. There can be internal energy change. Then there can be change in enthalpy, that is H. Enthalpy is basically heat or energy. Then there can be change in entropy, which is denoted by S. There can be change in Gibbs free energy. Gibbs free energy denoted by G. And there can be change in number of moles as well. So what happens when a reaction takes place? That means a system changes from one form to another. That means a reaction is taking place. During the course of reaction, there can be change in pressure. There can be change in temperature. There can be change in internal energy of the system. There can be change in enthalpy of the system. Sometimes exothermic reactions may take place. Sometimes endothermic reactions may take place. That is, sometimes heat may be evolved and sometimes heat may be absorbed also. There can be change in Gibbs free energy. Gibbs free energy means that energy of the system that is available for doing useful work. Then there may be change in G, this rather number of moles, and entropy also. Entropy means disorder in the system. For example, in this system the disorder is less, and then when it changes to system B it may be more or less than the first one. So these are some changes that take place during the course of a change, when a system changes from one state to another. Then these things which have changed during the course of reaction, these are known as state variables. State variables. These are all state variables. Now let me come to some thermodynamic processes. There are so many processes which are thermodynamic in nature. For example, let me take example. One is isothermal process. As the term suggests, these are those thermodynamic processes. These are all thermodynamic processes which I am going to list. Isothermal. Iso means same, and thermal means heat or temperature. Therm. So those thermodynamic processes which take place without change in temperature, or those thermodynamic processes where there is no change in temperature. That means, suppose if it is system A, it is getting changed to system B. Suppose its temperature was 25 degree at the beginning, and if it changes into B, if its temperature remains the same temperature, they are taking place, no change in temperature, then such a process is known as isothermal process. In isothermal process, delta T is always 0. That means here temperature was, in this example, 25 and 25. What is the change? 25 degree minus 25 degree, that is 0 degree. So there is no change in the temperature. So those thermodynamic processes, this is a thermodynamic process where there is no change in what? In temperature. However, there may be, if this is a system, these are surroundings, there may be exchange of heat from the system to the surrounding, or from surrounding to the system. There may be exchange of heat, but the total temperature of the system, that must remain same. If suppose temperature is positive, if suppose the reaction is exothermic in nature, then temperature will be increased. And if the reaction is endothermic in nature, then the temperature will fall. This is to be remembered. So these processes are known as isothermal processes. Coming to another type of thermodynamic process, number 2, adiabatic processes. Adiabatic. They are quite reverse of the isothermal. In this thermodynamic processes, the change in temperature is not equal to 0. That means temperature may change, temperature may increase, or temperature may decrease, and there is no exchange of heat between the system and the surrounding. That is, in this case, neither heat transfers from the system to the surroundings nor from the surroundings to the system. There is no exchange of heat in adiabatic thermodynamic process. Whereas in isothermal processes, there could have been the exchange of heat from the system to the surrounding, or from the surrounding to the system. But here in this case, please remember, in adiabatic processes, there is no exchange of heat, and such a system, such a process is always isolated in nature. Isolated means that such a reaction is taken in an insulated container. For example, a reaction For example, a reaction that is carried out in a thermos flask. A reaction which is carried out in a thermos flask is that's an example of adiabatic thermodynamic processes. Now coming to third type of thermodynamic process, that is isobaric thermodynamic process. Isobaric, then we have isochoric, then we have cyclic thermodynamic processes, then I have reversible these thermodynamic processes, and finally we have irreversible. Let me throw a light on all these processes. Coming to isobaric, bar stands for pressure and iso means same. So what are these thermodynamic processes? These are those thermodynamic processes in which delta P, that is change in pressure, is always equal to 0. That means suppose a system that is changing to system B, if this is taking place at a pressure of suppose 20 bars, when it changes to system B, its pressure should remain same, that is 20 bar. So there should be no change in pressure. So any thermodynamic process where there is no change in pressure, that is delta P is always 0, such a process is known as isobaric process. So bar for pressure, because the unit of pressure is bar. See, now coming to isochoric. Iso means same, and core means volume. So what is this process? This is that thermodynamic process in which delta V, that is volume, that is 0. That means there is no change in volume. Suppose this is a reaction taking place and suppose its volume is 20 liters. And if it changes to system B, its volume should again be 20 liters. So there is no change in volume. So when a process changes from one state to another and there is no change in volume, such a process is known as, such a thermodynamic process is known as isochoric process. For example, the reaction between hydrogen and chlorine to form hydrogen chloride is an example of isochoric process. In this example, the volume of these two is equal to the volume of this. That does not change at all. Now coming to cyclic process. Now what is cyclic process? Cyclic process means suppose I have some changes in the system. Suppose system first changes from A to B, then it changes to C, then it changes to D, then it changes to E, then it changes back to A. So this is a cyclic process. But during this process, series of steps have taken place. But during this process, delta E should be 0. Delta E means there should be no change in internal energy. That is, the energy at the beginning should be as it is in second, third, or in the final. This is the final stage. So as in cyclic process, delta E must always be equal to 0. That is, there should be no change in internal energy of the system. Now coming to reversible process. Reversible means if a system changes from A to B, it must reverse from B to A. And such processes are reversible. Why? Because basically they are slow processes. They take place slowly. That is why there is every possibility of reversing. So mostly slow processes get reversed. On the other hand, we have irreversible. In irreversible processes, what happens? A system changes from A to B, but it never comes back. Why? Because this process is very fast. Fast processes do not reverse. That is, they are irreversible in nature. So these are some thermodynamic processes. And that is all for today. Thank you very much.